All right. Hey, everybody. We are going to talk about topic 8 today. It's called other database structures. But basically what this topic is it is anything that isn't in a table form data, anything that isn't SQL. So this is kind of like the counterpart to SQL. And the specific NoSQL database that we're going to talk about today is MongoDB. MongoDB is a company that created this kind of database. There are other companies that do similar things as well. Even Amazon has their own version of this. But we're going to be talking about MongoDB. I have my terminal window shown here alongside this, because before I get into any of that, in order to have MongoDB working on your computer, there's something that I want to mention real quick. So in order to successfully connect to Mongo, what Mongo will do, it'll spin up a local server on your computer, and that's where your database is stored. So if on your Git bash or on your terminal, you have your Jupyter notebook running here, make a new tab. In order to have Mongo working, you have to have at least 2 Git bash tabs or windows, or terminal tabs or windows open simultaneously, because you need to be running the Jupyter notebook server as well as the Mongo server at the same time. So you need to have multiple Git bash / terminal windows open. So with this is open, one thing to note is that every system runs Mongo slightly differently. So within your labs, or I think they might link to different instructions depending on whether you're on a Mac, PC, Linux. So follow those instructions. If you are having trouble with launching Mongo and you really want to get this work done, please let me know, because that is something that is one of the more common things that I have to sit down with students and work through, because every system is slightly different. On the Mac, the way that I did it, I use it through Brew services. So it's actually through Homebrew. And so in the Mac, you actually have to run it 2 times. So, or run 2 different things. First, you have to start MongoDB community. So that's actually what I did here. You can see that it starts here, run MongoDB community, and then it runs this. And I'm just checking to see that the Mongo community is running. And only after Mongo community is running, then I can run Mongo. And so to run Mongo, and this is on a Mac specifically, to start the Mongo shell, you just have to type in Mongo. And you can see here, so there's a startup warning. This doesn't matter too much, but the session is running and it's connecting to this local URL here. I'll get back to this later, but I just wanted to show you all the setup to get Mongo working on your Jupyter notebook. This just has to be running in the background. Any questions about this before I get into what Mongo actually is? All right, let me just reshare my screen so it's less distracting. Okay, so now we're looking back at just the notebook. We'll get back to the code in a little bit, but I just want to give some background for what MongoDB is. So MongoDB is a kind of database that deals with document stores. So a document store is a database that records records as unique documents in the database. Basically, it'll look very, very similar. And in Python, we'll actually work with dictionary structures or JSON structures. It's flexible because these documents can be arbitrarily long and can even contain other documents inside of them. So, the nested dictionaries, the fact that your key values, different dictionaries within dictionaries can have different number of keys and values, so on and so forth. This blurb is taken from one of the labs, so it talks about this chat log, but the chat log is in one of your labs. Most importantly, within document stores, each document contains key value pairs, again, like dictionaries, with your actual data being stored in as the value. So therefore, it's very, very flexible because every document can be unique. There are no constraints saying what documents have to have what keys. So it's really, really great for working with data where you don't know what kind of shape it will take. And you probably don't even know what data will be stored at all. So let's say you have a bunch of data collection being done and there is not a lot of consistency, which is very normal in the real world. Not a lot of consistency. It's not in a in a format such that you can design a table or a data frame where you can have, consistent columns with not a lot of redundancy. So because of that, document store is very, very good. So more reading here, this does come from the lab, so I'm not going to go very much into it. But here are some Mongo install instructions. This session I'm going to be talking about is the CRUD process. I did talk about this with SQL, and for SQL, we really only talked about the read processes, but today we're going to talk about CRUD processes, create, reading, updating, and deleting for Mongo. All right, so what we're going to do and how we work with a Mongo database, which very similar to SQL is quite opaque. Like you cannot pull up the database and look at it unless you have some sort of third-party software to do so. The way that we work with MongoDB through Python is with the PyMongo library. So it's very, very similar to the way that we had like a cursor or a connection to a SQL database. We use PyMongo to make the connection between our Jupyter notebook or whatever Python code we're writing with the Mongo database. And we'll do a really, really simple example to just demonstrate these processes. Before I get into more code, in terms of context, contextually, when will you use Mongo? Pretty much for the rest of this program, we actually will not come back to Mongo. It's one of these things that is fairly good to know. One of the opportunities I see if you do want to implement MongoDB is maybe in your capstone project. If you want to use data that is most efficiently stored as a Mongo database, in a Mongo database rather than SQL tables, then you might pick up this code again and store your data as a Mongo database. All right, so let's walk through some code. We're going to import PyMongo because that is what we use to connect to the database. We're also going to import request and beautiful soup. So this is from web scraping. So it's going to be a preview of topic 10 that we're going to go through on Friday. But what I'm going to do is I'm going to web scrape a bunch of data and throw it into a Mongo database. So that's what that code is about. More about that on Friday. This line here basically connects your Jupyter notebook with the Mongo database. So here you can see that I have this URL here. The URL matches the URL that showed up in the terminal. Let me just reshare real quick so you can see. So this was earlier when I started up Mongo. It connects to this URL over here. So 27017. Let me reshare. Let's go back to our notebook. So that matches 27017. So that has connected to our Mongo database. In the labs, it does go more in depth into exploring the different parts of this local address. But here really quickly, we can take a look at databases that exist just by default. So here we have admin config local. These are just parts of the local address that exist by default, so don't worry about that. Quote database, because I've taught this session a couple times, I have that there, but this code that we have below it, we're going to create the code, the quote database in a little bit. Okay. So first, let's just grab some data. This is a cool preview of what we're doing on Friday. This is a website with a bunch of quotes. So you can see there's Einstein, J.K. Rowling, more Einstein, a bunch of quotes. And what we want to do is let's just take all of these quotes, save it as a dictionary, and store it in MongoDB. So I'll go into how to write this code on Friday, but essentially what this is doing is we are requesting the HTML content from this page, parsing through it, and saving our quotes. So if I run this real quick and use our function on this URL, quotes2scrape.com, which is this URL, we'll take a look and see what we have. So this is our data that we're going to put into MongoDB. The format of it is pretty consistent for now, but this is just a simplistic example to show what we can do. Basically, it's a list of dictionaries. Let's see how long this list is. Oops. The length of quotes for Mongo is there are 10 quotes, and within each quote, we have the actual quote itself and the author, and that's it. Very, very simple data, but it will be able to show what Mongo can do. All right, so we have a list of dictionaries. That is our data type for now. So now that we have our data set up, we'll put it aside and let's start setting up the Mongo database so that we can put our data into it. So there's a bit of a hierarchy. You have a database, which similar to a SQL database can have multiple tables. In the Mongo equivalent, you have a Mongo database. Within that, you have multiple collections. So within a database, you can have multiple collections, and each collection will be your bunch of dictionaries. So tables are equivalent to collections. Tables in SQL are equivalent to collections in Mongo, and then database level, they're the same. So that's kind of like the hierarchy terminology. So to do that, this is how you create a new database, and we want to assign it to a variable for now. So the way that we create this, very similar to creating a new key in a dictionary or a new column in a data frame, same syntax. So we're going to have a quote database, and then within the database, we're going to create the quote collection. So my collection equals to the database here, quote collection. So before, if you didn't have this yet, back here when you ran this earlier, at this point now you should definitely have quote database there. This code is here to just delete, not to delete the collection, but to empty out the collection. So we're going to empty out the collection here. It's very, very common that, especially when it's your first time creating a database, maybe you're still figuring out the best way to store your data, the format in which you're going to need your data for later. Very, very normal to just reset your database and re-siphon in data rather than going in and editing every entry one at a time. So because of this, it's pretty normal, especially as you're still working on something, to have a line that you can always run when you want to reset, your database or reset your code, so on and so forth. So that's what this line does. The delete many method empties out the collection. Cool. And this is just in case I had quotes there before that we're going to restart the session here. All right, so that's what list database names shows us all of our databases. And then let's not worry about this for now. Okay, so the line to insert a list of dictionaries as entries in a collection is very, very straightforward. You use an insert many. You can technically also do insert one. So a lot of these operations, we'll see that this is insert, there's find, there is update and delete. A lot of them have one and many counterparts. So you can either do things one at a time or a bunch at once. So in this case, let's just do it all at once. Dot insert many, and then I just feed in literally my list of dictionaries. So results equal to this. Now, this is an action, right? The fact that I'm inserting something is literally just an action. It usually should not, you would think instinctively, you should not return any information, right? So why are we storing this action as a variable? Very, very interesting to see. So we can have our database names again. Why we want to store our action as a variable is sometimes an action can have attributes that are useful to us. So one of the attributes that you can get is you can see the IDs of the entries that were inserted, just to check that things were being inserted. So we take a look at this, the inserted IDs. These are all automatically generated, and they're I think they're pretty much in order. The inserted IDs of our 10 quotes are these. These are automatically generated. These strings don't really matter, but it just goes to show that there are things that were inserted. And so successfully, we have stuff in our database. All right, so that was our create step. Next is our read step, querying data from Mongo. I will say that as a data scientist, this is probably what you will be doing the most of, just querying. So let's take a look. So in querying, you actually can do slightly more complicated things. Like in SQL, you know how you can do group bys and aggregates. You can do a bunch of functions within SQL as well if you want. With Mongo, you can't really do the same kinds of operations. You can't really do group bys because for group bys, it really only makes sense if you have a table with a bunch of unique entries, and it only really works if your schema of your data is consistent. And for Mongo, it isn't. If you want to really get into MongoDB, if you end up being like a MongoDB engineer, Mongo actually has their own query language. These methods that we're using are not exactly Mongo query language. These come from PyMongo. So there's a good distinction between that. This is us using MongoDB within our Jupyter notebook, which is different from if you want to directly access your MongoDB database. I think Mongo has their own like software where you can interact directly with data there. But for our purposes, if there's an existing MongoDB database somewhere that we want to connect to and we want to, use the data, which is very, very likely if you are, working for a company that stores their data in Mongo. As a data scientist, you will likely be doing the most in this step. For now, I do think it's good enough to just know how to find what you need to find. And so they use their finds as they take in dictionaries when you want to find things. So, and you want to search by key and value. So quite straightforward, and it does make a lot of sense. We can find the quotes where basically find the dictionaries where the author is Albert Einstein. Let's take a look and see what happens here. When we just straight up run this, we are returned with a cursor object. Again, kind of opaque. We don't really see what's going on. What's different here is, again, we have an action, but for Mongo and for PyMongo, it makes sense to save that action as a variable. So what we're doing here is let's just save this cursor to query. And then we can actually loop through query and print the result of the query. Exactly why this works, you would have to look into the backend of how Mongo is set up. I personally haven't looked into that yet either. I really only needed to use Mongo one time ever for a project that I decided to do on my own. So this did work. This was good enough for all the things that I needed to do. So anyways, I was looking for all the quotes where the author is, in this case, Steve Martin. Let's take a look at the query. We have one single quote. A day without sunshine is like, night. And that's our one quote by Steve Martin. I think Albert Einstein had a couple quotes, so let's take a look and see what that gives us. Albert Einstein gives us our 3 Albert Einstein quotes. Cool. So if you ever needed to find information, you can do this. What you can also do is save these dictionaries into a Python variable as well. And then you'll be able to do whatever you need to with this data here. All right. I will say the next 2 steps of like updating and deleting from Mongo, unless your role is more like a data engineer or some sort of like database administrator, you probably will not need to do this, but good to know that you can if you need to, especially if you are creating your own MongoDB database for your project in the future. So to update data to Mongo, one easy one, or probably the most common thing you would need to do, is add additional data to existing data points. So let's say we have our dictionaries of quotes. Right now it's just the author and the quote itself. Let's just say I want to add some tags, some searchable tags to our dictionary. So one way to do it is each quote is probably going to have a different set of tags. So let's just say that, okay, I want to add these tags of like change, deep thoughts, thinking, and world. I want to add these tags to a Steve Martin quote. So first you have to define, what you want to add. You also need to define what subset of data you want to update. So in this case, I just want to update any quote whose author is Steve Martin. And then this is how the syntax is for updating. So this $set is basically the update query or the update function. And then you're setting your quote tags to be equal to Steve tags. So your quote tags is this new key that we're adding. And then Steve tags is this list right here. And then to update, you have to do an update one. You can do update many as well. I can show an example with Albert Einstein later because Albert Einstein does have 3. But we can do update one, update Steve, which is the subset of data that we want to update, and then what data we're updating it with. So here, the Steve quote tags. So with this, let's run these 2. And it does show you that it's been updated. We can now re-query Steve Martin and see what it looks like. All right, so now Steve Martin, you can see that we have the ID, we have the quote, the author, and also the quote tags that we added. Awesome. So as another example, just to show the one in many counterpart, let's hope that this works on my first try. If we do Einstein tags, and I don't know, Einstein's pretty smart, so let's just say that it's smart. And then let's have the author be Albert Einstein. And then let's do quote tags equals to Einstein tags. And then this will be Steve, let's call it Albert quote tags. I just make sure that everything is updated. Update Steve, oops, update Albert. Update Albert as well here. Just make sure that everything is good. Einstein tags. And here, instead of update one, we'll do an update many. And then that runs. And then let's take a look at our Albert Einstein tweets. There we go. So now in our Albert Einstein quotes, every quote has this additional quote tag of smart. So this is a way that you can update multiple things in your existing MongoDB database. All right. Well, to quickly round this off, deleting data. So you can delete one, you can also delete many. So first, the syntax is actually very, very similar to querying, but instead you're deleting. So instead of find, it will be delete one. And then we're looking to delete anything by Albert Einstein. So let's do that real quick. And here, one of the parameters of a deletion action is the count. So we can see that we've deleted one. Cool. And let's do a find of Albert Einstein again. So instead of 3, we're now down to 2. Let me double check. I forget if this delete many also works. Delete many, you can see here that is deleted 2. And if I try and do a find on Albert Einstein, nothing comes up anymore. So that's, again, another example to show how we have the one and many counterparts for Mongo. But yeah, I would say MongoDB is something that's pretty specific. I only have, out of my own students, one student that uses MongoDB at their job. And interestingly, it's because she does work at MongoDB. But yeah, it's just one of many ways you can store this kind of data. Amazon Web Services has their own version as well that you could explore later on. And also really depends on what the company is already using, but they all have quite similar queries and query functionalities. And also we'll probably have a similar way to interact with Python as well. So I feel like if you know the functionalities of one, you can sort of get a sense of the functionalities of others. But yeah, that's MongoDB. Does anyone have any questions regarding this? Going once, going twice. All right, let me stop this recording.